Am I audible, all of you? Can everybody hear me clear? um, okay, fine. All right, let us get started, everyone. My name is Ranjeet, and I will be teaching you maths. And today we are going to do a little bit of foundation course. Or to be more precise, I call it as the bridge course. Now, I'll tell you what this bridge course is all about. Now you have given your 10th standard, and now you will be going into the 11th standard. So there are many concepts which you have learned in 8th, ninth, and 10th, which you will be needing in 11th and 12th. But the thing is that it's been very long since we have learned those concepts of 8th, ninth, and 10th. अब उसे पढ़े कम से कम हो गए हैं 1.5 से 2 साल. So there is a huge possibility that those things might have erased from your memory. So we have kept this session where we can recap and revise all the concepts which we have studied in 8th, ninth, and 10th, which we will be requiring in 11th and 12th. So I'm not going to teach you the entire portion of 8th, ninth, and 10th, only particularly those concepts which we are going to require in 11th and 12th. Yeah, somebody says that my video is off. So that's perfect. My video will be off. You can see me writing on the screen. So that is where you have to focus. So I'll tell you in short what all things I'm going to teach you. I'll be teaching you few things like rationalizing the denominator. And I'm sure everybody must have done this rationalization in your previous classes. I will be teaching you identities. There are so many identities which we have learned in the previous class. We remember a few of them, like a plus b the whole square, which is a square plus b square plus 2ab. Or we know a minus the whole square. We know a square minus b square, because other than these also there are many identities. So we will take a recap of those identities also. Then we are going to learn something about exponents. Then we are going to learn factorization. Then we will be taking a recap and we will revisit how to solve the equations which involve quadratic equations and simultaneous linear equations. So these are few things which we are going to study in our bridge course session. So today, first of all, we are going to start with the rationalization of the denominator. So this is something which I'm sure almost all the students attending this session, they know it. So most of the things which we will be doing today, you have done it. And if you remember those things, it will be kind of fun to do all those things today. Okay, so let us begin with rationalizing the denominator. Now, what do we exactly mean by rationalizing the denominator? Now, whenever you have a fraction, whenever you come across a fraction where you have an irrational number in the denominator, say, for example, you have a number like 2 upon root 3. Now, you notice that root 3 is an irrational number. So we do not tend to keep irrational numbers in the denominator. So it is general idea कि denominator को भाई हमेशा rationalize ही करना होता है. We always have to keep the denominator rational. How are we going to do this? It's very simple. See, whatever the irrational denominator is, whatever is the irrational denominator, simply pick that and multiply it in the numerator and the denominator. Denominator का जो root 3 है ना, उसको root 3 upon root 3 से multiply कर देना है. Take the irrational part of the denominator, multiply it in the numerator as well as denominator. Now many students wonder कि ये ऐसे कैसे कर सकते हैं हम लोग. अच्छा खासा एक फ्रैक्शन था 2 upon root 3. All of a sudden हमने उसको root 3 upon root 3 से multiply कर दिया. So this is like altering the question. But I'll tell you something. See, 5 upon 5 is 1. 2 upon 2 is 1. 10 upon 10 is 1. Similarly, root 3 upon root 3 is 1. So when we multiply it by root 3 upon root 3, we are in short multiplying it by 1. So when you multiply anything by 1, the value doesn't change. The value doesn't change, only the form changes. So the numerator gets multiplied by the numerator So you have 2 root 3, and in the denominator, root 3 multiplied by root 3, that becomes 3. So here your procedure is completed. Perfect. Yes, we multiply root 3 upon root 3, which in simple language means we are multiplying it by 1 in disguise. Fantastic. Let's try another one, all of you. I hope you have your books and pen and stationery ready with you. So these are few things which you people already know. So it's kind of fun to do it again. Okay, so this is the second one. Now we got to rationalize this. So, so 3 upon 5 root 2. Now we only pick the irrational part of the denominator. The denominator consists of a rational part and an irrational part. So since we need to rationalize the denominator, we only pick the irrational part, that is root 2. Do not multiply it by 5 root 2 upon 5 root 2. And even if you multiply by 5 root 2 upon 5 root 2, your answer is not wrong. You will still get the correct answer. So 3 multiplied by 5 is, 3 multiplied by root 5 is 3 root 5. So 5 into, see, root 2 times root 2. Root 2 times root 2 is 2. So we get 3 root 5 upon 10. And once you observe that the denominator has become rational, your mission is accomplished. You have rationalized the denominator. Okay, let's try another one. Again, this is an easy one. Let's see how many if you can do this one. So 5 root 7 upon root 5. Okay, so there are a few questions in the chat. Let me just address those questions. Oops, I made a little mistake over here. I'm sorry. It's, just pardon me. It is basically root 5 upon root 5. My bad. One second, students. So it's 3 upon 5 root 2. So the irrational part is root 2. So we multiplied by root 2 upon root 2. So whoever pointed it out, thanks for pointing it out. So we have 3 root 2 multiplied by 5 into root 2 times root 2 is 2. So it's 3 root 2 upon 10. This is the correct answer. All right, let's come to this one. So we have 5 root 7 upon root 5. So how are we going to this? So root 5 upon root 5. We take the irrational denominator, multiply it up and down. So that is 5. Now root 7 multiplied by root 5. You multiply both of them, it turns out to be root 35. Now root 5 into root 5 is basically 5. Now 5 and 5 gets cancelled out. So you're left out with root 35. So this is your final answer. So students are very quick and very prompt in giving the answers. That's amazing. That's awesome. Perfect. So now let us have two terms in the denominators. अब हम लोग ऐसे denominators को rationalize करेंगे. What is the topic? Okay, the topic is basically bridge course. We are going to do a lot of concepts of 8th, 9th, and 10th. So the current topic which is going on is rationalizing the denominator. Okay, here we go, students. Now we are going to rationalize where we have two terms in the denominator. That is root 3 minus root 2. So do you people remember how we used to rationalize this when we had two terms in the denominator, root 3 minus root 2? Again, I'll tell you. So what we do is we take the conjugate of the denominator. We take the conjugate of the denominator. Now I'll tell you what the conjugate is. Conjugate का मतलब होता है same terms but the opposite sign. Root 3 minus root 2, that is our denominator. You see the connecting sign is minus. Now, if you want to take the conjugate of it, it is going to be root 3 plus root 2. That is same terms, but the reverse sign. Conjugate is also sometimes called as the rationalizing factor. Okay, perfect. So most of the students know that. So we have the conjugate of root 3 minus root 2, that is root 3 plus root 2. और यही सेम चीज हम लोग को मल्टीप्लाई करनी है न्यूमरेटर में भी. So 1 multiplied by root 3 plus root 2. The numerator gets multiplied by the numerator. So 1 multiplied by root 3 plus root 2 is root 3 plus root 2. And whenever you do such a kind of a rationalization, you will always end up getting a form of a minus b into a plus b. ये तो आना ही आना है. If you're going to multiply by its conjugate, so a minus b into a plus b is pretty obvious. And now you people very well know what a minus b into a plus b is. It is a square minus b square. A square minus b square. In the place of a, here we have root 3. In place of b, here we have root 2. So root 3 minus root 2 into root 3 plus root 2 is root 3 square minus root 2 square. So let's go ahead. So we have root 3 plus root 2. Denominator में root 3 square. Now root 3 square turns out to be 3. Root 2 square turns out to be 2. So we have root 3 plus root 2, the whole upon 3 minus 2 gives us 1. And anything having 1 in the denominator is the same thing, which is as good as root 3 plus root 2. See, pretty cool and easy. So let me see what students have given the answers over here. Yes, perfect. So there are many students who are giving the answers very quick. And one of the students has asked, "Ki, sir, ye likhna hai?" Yes, of course, ye likhna hai. We are definitely going to write this. Sadiq, actually going to the previous slide is a little difficult for me because it's gone, but no problem. You focus on this slide right now. Sir, the conjugate is always positive. No, it is not necessary. It is the reversed sign. If over here you have a minus sign, then the conjugate will have plus sign. But if it would have been plus over here, the conjugate will have a minus sign. All right, now somebody wants difficult questions. Perfect. Chalo. Let's first focus on the easier ones, then I'll give you the tough ones. Root 2 upon root 5 plus 2. Now this is the second one. Root 2 upon root 5 plus 2. So now tell me, students, what do we do over here? Root 5 plus 2. We got to take the conjugate of the denominator. Now here the denominator is root 5 plus 2. The root 5 plus 2 का जो conjugate है, that is going to be root 5 minus 2. That is going to be root 5 minus 2. And the same thing, we are going to multiply it in the numerator also. Root 5 minus 2. So this is called as rationalizing the denominator. And after that, we start with the simplification process. Very simple. Root 2 gets multiplied by root 5 minus 2. And in the denominator, as we always know, we will be getting the form of a plus b into a minus b, which turns out to be a squared minus b squared. That is root 5 square minus 2 square. Let us open the brackets in the numerator. So root 2 gets multiplied by both of them. So what do we have over here? Root 2 into root 5 turns out to be root 10. Root 2 into 2 becomes 2 root 2. In the denominator, we have root 5 square. Well, root 5 square is simply 5, and 2 square turns out to be 4. And so we have root 10 minus 2 root 2, the whole upon 5 minus 4 is 1. And we have already seen that anything which has a denominator 1 turns out to be the same thing. Root 10 minus 2 root 2. So this happens to be your final answer. Well, I hope you got this one. Perfect. I'll give you one more. Let's try this one. I hope everybody's done writing. Can I go to the next slide? Okay, perfect. Chalo, let's try this one. 5 upon 4 root 3 minus 3 root 2. Okay, let's try this one. 5 upon 4 root 3 minus 3 root 2. So once again, we're going to do the rationalization. And you people very well know how rationalization takes place. So this is 4 root 3 minus 3 root 2. Simply take the conjugate of the denominator. And you now know what conjugate is. That is the same terms, but the opposite sign. And the same thing you multiply it in the numerator as well. This is what you get. Now the numerator get multiplied by the numerator. So what do we have here? 5 multiplied by 4 root 3 plus 3 root 2. And the whole upon, and denominator we know we're going to get a form of a minus b into a plus b, turns out to be a square minus b square. 4 root 3 square minus 3 root 2 the whole square. All right. Now in the numerator, students, we are not going to open the brackets. We will keep it as it is. Keep the 5 as it is. And in the end, when we will have the final answer, that time we will open the bracket and see what happens. Chalo. In the denominator, goodness, you people are so quick. The students are giving the answers so fast. All right, let us see in the denominator. Now this square is applicable to both of them inside the bracket. Over here, you can just follow the red dot. The square outside is applicable to 4. It is also applicable to root 3. Now 4 squared becomes equals to 16. And root 3 squared becomes 3. Okay, let's proceed again. See, as I've told you, this square over here is applicable for 3 as well as root 2 inside the bracket. So what do we have? 3 squared turns out to be 9. And root 2 squared turns out to be simply 2. So once again, as we know that we are not opening the brackets in the numerator as such now, keep it as it is. Now 16 threes are 48 minus, and 9 times 2 is 18. Let's proceed for 5 times 4 root 3 plus 3 root 2. So let's see what we have in the denominator. 48 minus 18 turns out to be 30. Now see, we can reduce 5 and 30. That is the reason why we did not open the bracket with 5. We always do that in the end. Say if nothing would have been cancelled, so that time we open the bracket. But now we have that advantage of reducing this. So now you can see we are at the final answer. 4 root 3 plus 3 root 2 the whole upon 6. We have rationalized and simplified the denominator to just be 6. So I hope this is clear all of you. Let's see what people have written in the chat. 70 chats in one sum. Amazing. Great. Yeah, I generally do not find students who remember all the concepts of 8th and 9th and 10th. Because when they come in 11th standard and when we do all these things, तो बच्चे बोलते हैं कि ये कहाँ से आ गया भाई, ये आया है 9th और 10th में से, और वहां पर हमने ध्यान नहीं दिया या हमने सीरियसली नहीं लिया और वो हम भूल चुके हैं. तो वो सिचुएशन हमारे साथ अराइज ना हो, इसके लिए वी हैव अरेंज दिस सेशन. And now there are some really brilliant students I can find in this group who are very quick in doing. चलो एक काम करते हैं, let's try the next one. चलो. Yes, yes, of course. Okay, let us have 3 irrational numbers in the denominator. इस बार डिनोमिनेटर में हम 3 इरेशनल नंबर्स लेते हैं, 3/√3 minus √2 plus √5. Now tell me students, how do we do this one? इसे कैसे करेंगे हम लोग? This time we have got 3 irrational numbers in the denominator, so we are going to group any 2 of them. तो we are going to group 2 of them. तो जो पहले वाले दो है ना, उनका एक ग्रुप बना लेते हैं, √3 minus √2. So group them together by putting them in a bracket plus and leave √5 alone. तो it's हमने √3 minus √2 को एक ग्रुप बना लिया. Now if you can see, we are going to consider this as one term for now. ये हमारा पहला टर्म है और ये हमारा दूसरा टर्म है. So now you know the conjugate thing, how it is done. Multiplied by the conjugate of the denominator. So we have √3 minus √2. Nothing changes inside the bracket because the sign inside the bracket is protected. और वो जो प्लस है ना, वो definitely minus बन जाएगा because that is the connecting sign. So I'll tell you this sign changes. Correct. और यही जाएगा न्यूमरेटर में, which is √3 minus √2 minus √5. All right. So now what do? We multiply the numerator and the denominator with the denominator. So here we go. 3 multiplied by √3 minus √2 minus √5. तो ये पूरा का पूरा न्यूमरेटर में हम उसको 3 से मल्टीप्लाई करेंगे, right? And then in the denominator, if you observe, now we have √3 minus √2 the whole square. A square minus b square होता है ना, तो see ये पूरा का पूरा ना हमारे लिए ये है a. This is a plus b. This is a minus b. So a for us is √3 minus √2. तो a square minus b square का मतलब √3 minus √2 the whole square minus √5 square. We keep the numerator as it is for some time. देखेंगे बाद में जरूरत पड़ा तो फिर हम लोग उसको कैंसिल करेंगे डिनोमिनेटर के साथ. तो there is nothing to worry in the numerator for now. Minus √5. In the denominator, now you look at this part, √3 minus √2 the whole square. Now I have seen so many students making a very common mistake over here. देखो बहुत बच्चे क्या करते हैं पता है, √3 minus √2 the whole square. I have seen students coming in 11th standard and making this mistake. तो वो क्या करेंगे, ये इसको स्क्वायर कर देंगे और इसको स्क्वायर कर देंगे. तो they will write it as √3 squared is 3 and √2 squared is 2 and this comes to be 1. Never ever do this mistake in your life. Please, ऐसा नहीं करना ये. Consider √3 minus √2 the whole square as a minus b the whole square. इसको आपको है ना a minus b the whole square consider करना है. And you have to expand it like this. So √3 the whole square minus 2 into √3 into √2 plus √2 the whole square. That is a square minus 2ab plus b square. इसे इसी तरह से expand करना होता है. तो चलो, let us do the expansion. √3 minus √2 the whole square in the denominator. √3 square. √3 square is 3. 2ab, that is 2 into √3 into √2, that is 2√6. √2 square, that is equal to 2. I hope everybody is clear with this. √3 squared is 3. फिर ये minus आ गया. फिर it is 2ab, that is 2 times √3 into √2, that is √6, plus b square, √2 square is 2, minus √5 square is 5. Keeping the numerator as it is, let us simplify the denominator a little more further. All right, so what do we have? Let us see in the denominator. We are having 3 plus 2, 5, and 5 minus 5 is 0. तो यानी कि आप देखोगे 3 plus 2 minus 5. It all gets cancelled out. And we are simply left out with just minus 2 root 6. All right, perfect. Minus 2 root 6. चलो, जब तक डिनोमिनेटर में आखिरी तक कोई रैशनल नंबर इरैशनल नंबर टिका होता है ना, तब तक हम ये नहीं कह सकते our rationalization is complete. We can still spot one root 6 over there. So tell me students, now what do we do with this root 6? We are going to further rationalize it. Yeah. जब वो डिनोमिनेटर से रूट 6 निकल जाएगा, तब हम कहेंगे yes, the denominator has turned the into a rational number. So let us proceed further. So, all right, 3 times root 3 minus root 2 minus root 5 upon minus 2 root 6 multiplied by, so we are going to rationalize it by root 6 upon root 6. So the numerator gets multiplied by numerator and the denominator gets multiplied by the denominator. तो ये जो root 6 है ना, हम ब्रैकेट के अंदर इसमें सबको मल्टीप्लाई कर देंगे. We are going to multiply it by all the terms by root 6. Keep 3 as it is. Root 3 multiplied by root 6 is going to give us root 18. Root 2 multiplied by root 6 is going to give us root 12. Root 5 into root 6 is going to give us root 30 upon 2. Now root 6 into root 6. You know what root 6 into root 6 is? It is simply 6. Right? Perfect. Very nice. So let's go further. So can we simplify something? We can cancel out this 3. So this is and the minus sign, of course. Yes. So 3 ones are and we have 3 twos are. Correct? तो जो चीज बच गई है ना, हम उसे लिख देते हैं. So root 18 minus root 12 minus root 30, the whole upon we have minus 4. Now you see the numerator and the denominator. इसको जरा एकदम ध्यान से देखो. Do you see that we can simplify root 18, root 12 and 30? Correct. Root 18 जो है ना, okay, perfect. Now the students are giving so many answers on the chat, the screen jam ho jati hai. Okay, tell me root 18. How do we write root 18 as? Fantastic. 9 into 2 minus. What about root 12? How do we write root 12? That is going to be 4 into 3. And what about 30? Root 30. We can write it as 5 into 6. We can write it 5 into 6, but that is not going to make any difference because whenever we do that, it has to be such that one of the numbers has to be perfect square. So 30 can be written as 3 into 10 or 5 into 6. All right. Then upon minus 4. Now this 9 comes outside and becomes what? This is going to be 3 root 2 minus 2 root 3 minus root 30, the whole upon minus 4. So finally, we have managed to rationalize the denominator. So this is your final answer. And as per the rule, we also do not keep negative in the denominator. हम denominator में negative नहीं रखते हैं, और अगर denominator में negative आता है, we simply take that to the numerator. तो ये minus के sign को जब numerator में ले जाएंगे ना, तो all the signs are going to get reversed. So minus 3 root 2 plus 2 root 3 plus root 30, the whole upon 4. So now your denominator is simply 4. And those who have got this answer correct, I'm really happy for them. So that's perfect that you people still remember and do these calculations and get the right answers. So once you're done, just let me know. Then we'll go to the next concept. So we are not going to spend a lot of time learning only rationalization. बहुत सारी चीजें हमें सीखनी है. Now we are going to learn identities and their applications. Okay, I'll anyhow wait for another 10-15 seconds. Yes, we can do that way. Perfect. Some of the names sound very familiar to me. I do not know why. Trigonometric identities. Yes, yes, of course we will do trigonometry, but not today. सारी चीजें हम आज ही नहीं करेंगे. All right, chalo. See, we are going to learn the identities now. Okay, are there some students who are attending this for the first time? Okay, perfect. So there are many students who are attending this for the first time. Fine, fine, perfect. Let's start. All right, everyone. Perfect. Let's proceed further. Okay. Now we're going to learn the identities and their applications. Now I'm sure you people must be remembering these identities. Let us see how many of you remember this. The first one, that's the most basic one, basic of all of them. A plus B the whole square. Now this is one of those identities which we are never going to forget in our entire lifetime. Only for a very simple that we have used it every now and then in mathematics. जो चीजें हम बहुत ज्यादा frequently use करते हैं वो हम भूलते नहीं हैं. We tend to remember that. And likewise, A minus B the whole square. So it's going to be A square plus B square minus 2AB. And then the third one, that is, अच्छा अब third और fourth देखते हैं. Yeah, this is we are going to now learn identities and the application of the identities. Somebody was asking the name of the topic. It is identities and the applications. अब ये जो third identity or fourth identity which I'm going to teach you, this is one big time saving identity. It's a very big time saving identity. Please take a special note of identity number 3 and identity number 4. So what we are going to do over here in 3 and 4 is we are simply going to add the first and the second identity. See, the first identity is A plus B the whole square. The second identity is A minus B the whole square. We are going to simply add it. हम इन दोनों को add करेंगे. It is the addition of the first and the second. So if we add this, you know what happens? I'll just tell you. See, plus 2AB minus 2AB gets cancelled out. Plus 2AB minus 2AB gets cancelled out. And what remains in the end is A square plus B square plus B square, which is 2 times. It's 2 times A square plus B square. See, you can easily notice here A square plus A square, 2A square, B square plus B square, 2B square. So it's 2 times A square plus B square. इसे याद रखना. बहुत सारे ऐसे चैप्टर्स है जहां पर हम लोग को ये यूज करना पड़ता है. और अगर हमको ये आइडेंटिटी याद नहीं है तो then we end up expanding both of them and simplifying and then reach to this conclusion. बट अगर ये आइडेंटिटी याद है तो हम डायरेक्ट इसका रिजल्ट लिख सकते हैं. अब आइडेंटिटी नंबर 4 में हम इन्हीं को सब्ट्रैक्ट करेंगे. So we have A plus B the whole square. In the place of plus, we are going to put minus this time. So we are going to subtract both of them. So अब इसमें होगा क्या? देखो फर्स्ट आइडेंटिटी में ना 2AB कैंसिल हुआ था ना. अब इधर A square B square कैंसिल हो जाएगा. So you will end up getting 2AB plus 2AB. Yes, many of the students have given the right answer. Perfect. It's 4AB. That's great. No, it's not 2AB, it's 4AB. Yes. AB plus AB, 4AB. All right, let's proceed further. Now we come to fifth one. See, the most popular of all of them, A square minus B square. So it is a plus b into a minus b. That was a very easy one. Now let us come to the cubes. I remember in the beginning of the session itself, one of the student asked, "Okay, sir, a plus b the whole cube kya hota hai?" So finally, we are now at a plus b the whole cube. A plus b the whole cube is equal to, and then of course, a minus b the whole cube also after that. See, it is a cube plus b cube plus 3ab. In the bracket, we have a plus b. A cube plus b cube plus 3ab into a plus b. Yes, Siddhesh, you're correct. Now, many of the students, they remember this being taught in the school as a cube plus 3a square b plus 3ab square plus b cube. बचपन में ही हम लोग को ऐसे भी सिखाया जाता था. But this is a better and efficient way of writing it. A cube plus b cube plus 3ab into a plus b. And now we come to a minus b the whole cube. अब इसमें होगा ये that the terms are going to remain the same, but we are going to reverse all the signs inside. तो देखो a cube minus b cube minus 3ab a minus b. All the signs have reversed except a cube. तो अंदर के सारे साइन बदल चुके हैं. इसके अलावा एक आध आइडेंटिटी और भी है जो मैं आपको धीरे धीरे सम्स के दौरान बताऊंगा. I'll be telling you that. Yes, Arshal, you're correct. That is for a cube plus b cube. Amazing. There are few identities which I'll be teaching you as and when we start doing these sums. So up till now, amongst all these identities, आपको इसमें से जो नहीं आती थी वो आप नोट डाउन कर लो, और जो आपको आती है फिर वो लिख के मतलब नहीं बनता. We will be wasting our time. So you feel कि इसमें से जो important है, जो आप भूल चुके थे, you write that down. Done writing. Fantastic. Awesome. That's great. Perfect. Yes, Vidhi, you're right. We have an identity of that kind. But for that, a plus b plus c has to be equal to 0. Yes, yes, you people remember a plus b plus c the whole square. Yes, it's a square plus b square plus c square plus 2 in the bracket ab plus bc plus ac. Okay, so you have already attended this. Perfect. Chalo, let's proceed further. Now, coming to, yes, I will teach you the slope of the line. I'm going to teach you. Don't worry. Let us do a few more things of this type. And then in the next session, I'm going to teach you some technical things, okay? Because there are many students who have attended this session. This is their first time. So they might have missed out on all this. I think so some of the students who have already attended. तो आज सबके लिए commonly cater करते हैं. So in the next session, in the next session, we will do something more technical, which is of big importance for 11th and 12th. So coming over this, all right. Chalo, let's try this one. If 3x plus 4y is equal to 16, and we have been given the value of xy. The value of xy is equal to 4. The question is, find the value of 9x square plus 16y square. All right. Many times we come across a situation like this. Tell me, which identity are we going to use over here? कौन सी identity हम लोग use करेंगे? Now, perfect. Very good. Yes, everyone is correct over here. All the students who have given the answer, everybody is correct. Now see, if you can look over here, we have 3x plus 4y, whose value is 16. And we got to find 9x square plus 16y square, which also happens to be the square of 3x. 16y square is the square of 4y. So we are simply going to pick up 3x plus 4y equals to 16 and square it up. Let's do that. Here we go. 3x plus 4y is equal to 16. And the reason for this is simply given. ये हम लोग को दिया हुआ है. Now, if we square this, somewhere or the other, we are going to end up getting 9x square plus 16y square. Okay, let's go ahead squaring it. 3x plus 4y, the whole square, is equal to 16 square. So this is squaring both sides. All right. Now we're going to expand this in the form of a plus b the whole square. If you remember, it is a square plus b square plus 2ab. तो a square का मतलब हो जाएगा 3x the whole square plus 4y the whole square plus 2ab, that is 2 times 3x 4y, is equal to 16 square. How much is 16 square? It's 256. All right. Now 3x the whole square is going to be 9x square. 4y the whole square is going to be 16y square. Plus, now 2 times 3 is 6 and 6 times 4 is 24. So we have 24xy is equal to 256. Now the question tells us to find the value of this 9x square plus 16y square. देखो ना, यही हम लोग को पूछा गया है. तो अभी हम कैसे find करेंगे? See, it's very simple. We already have perfect. So many students have given the answer. xy का value तो हम लोग को already पता है. देखो question में दिया हुआ है. We have the value of xy, and the value of xy, to be very precise, is 4 if you see in the question. Perfect, you're right. All right. So we have 9x square plus 16y square plus 24 into 4 is equal to 256. So 9x square plus 16y square. Now 24 into 4 is going to give us 96, which we are going to shift it on the right hand side. So minus 256, which gives us 160. And most of the students already gave the answer the moment I wrote the question. That was really quick and very impressive. Yes, 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 perfect. That's good. That's really nice. But can we try the next one now? Okay, here we go. The next one. See, now here the value of a plus b. A plus b is equal to 6. The value of a minus b is equal to 4. The question tells us to find the value of AB. And after that, we will also find a square minus b square. दोनों find करेंगे. चलो, अब देखो इस क्वेश्चन को ध्यान से और थोड़ा सा चलाओ दिमाग. मैंने आपको कहा था ना कि आइडेंटिटी नंबर 3 और आइडेंटिटी नंबर 4, they are very important. तो if you see that identity number 3 and 4, tell me कौन सी वाली यूज करेंगे हम लोग यहाँ पर? Check. I'll just write the identity once again because वो screen निकल गई है. A plus b the whole square plus a minus b the whole square. Now if it is plus, that is going to be 2 times a square plus b square. Then we have a plus b the whole square minus a minus b the whole square is equal to 4ab. Tell me, students, which one we are going to use. See, now, as far as the given information is concerned, we see that we have a plus b, we have a minus b. हमारे पास ये दोनों है, तो देखो ये दोनों भी आइडेंटिटी में a प्लस बी a माइनस बी इन्वॉल्व होते हैं, बट डिपेंडिंग अपॉन व्हाट वी हैव टू फाइंड आउट, वी आर गोइंग टू डिसाइड व्हिच वन टू यूज। ए बी जो है, अभी इस केस में यू कैन सी ए बी जो है वो सेकेंड वाली आइडेंटिटी में नजर आता है, तो वी आर गोइंग टू यूज दैट वन, राइट? So this is going to be a plus b the whole square minus a minus b the whole square is equal to 4 times ab. It's 4 times ab. Okay, so let's put all the values over here. A plus b the whole square, that is simply 6 square. A minus b the whole square, that is going to be 4 square, which equals to 4ab. Now this is going to be 36. This is going to be 16 equals to 4ab. Now 36 minus 16 is going to give us 20 equals to 4 times AB. And we get the value of AB is equal to 5. This is the answer. Fantastic. Good. सब लोग ने आंसर्स दे ही दिए. Amazing. चलो, let us now find a square minus b square. अब a square minus b square, you people all know this is going to be very easy. It's simply a plus b into a minus b. And we have both the stuff ready with us. A plus b भी तैयार है और a minus b भी तैयार है. It's going to be 6 into 4. So we have a square minus b square is equal to 24. And done. Easy peasy. Yes, Nupur, you can do that. All right. Chalo, great. Let's try the next one now. See, I'll tell you something over here. One more thing. Now, if we have a situation like sum of three terms, a plus b plus c, sum of three terms, if it turns out to be 0, if a plus b plus c turns out to be 0, if, then finding their cubes is very easy. Then if you have to find the sum of their cubes, that is a cube plus b cube plus c cube, uska jo value hoga, that is simply going to be 3abc. 3abc. Correct. But a क्यूब प्लस बी क्यूब प्लस सी क्यूब का वैल्यू 3abc होने के लिए पहला कंडीशन ये है कि a प्लस बी प्लस सी 0 होना चाहिए. That is the most important condition. So let us try this. See, now 3 cube, let us do the evaluate 3 cube plus 2 cube plus minus 5 cube. Let's figure this out for ourselves. अभी हम लोग को ये evaluate करना. Let us do that manually. तो हम लोग ना साइड पे मैनुअली क्विकली करके देख लेते हैं. प्लस 2 क्यूब प्लस माइनस 5 क्यूब. ओके, टेल मी स्टूडेंट्स, हाउ मच इज 3 क्यूब? 3 क्यूब इज 27. Awesome. 2 cube is 8. Acha. And minus 5. That is going to be minus 125. Minus 125. So we have 27 plus 8 and minus 125 turns out to be minus 90. So we have already got this answer, and now we are going to check our identity, whether our identity does really give this answer or not. तो अपने आइडेंटिटी के लिए सबसे पहले हम लोग को फाइंड करना है कि a plus b plus c 0 है कि नहीं. तो let us consider our a as 3, let us consider b as 2, and we consider c as minus 5. चलो इनको ऐड करके देखते हैं. a plus b plus c equals to 3 plus 2 plus minus 5, which turns out to be 5 minus 5 equals to 0. So now since a plus b plus c has become equal to 0, let us check if a cube plus b cube plus c cube का value 3abc है या नहीं है. So 3 cube plus 2 cube plus minus 5 the whole cube should become equal to 3 into 3 into 2 into minus 5. Multiply the students together. 3 threes is 9 and 9 twos is 18. 18 multiplied by minus 5 turns out to be minus 90. So you see, we got the correct answer. Eitherwise, we did the manual calculation, got minus 90. We used our identity and we still got the same answer. That's brilliant. Perfect. Acha, chalo students, now without wasting any time, let's do the next part. अब हम लोग है ना आगे चलते हैं. Now we are going to learn the indices. I'll tell you, indices is one very important thing. Okay, somebody wants to see the previous slide. Here we go. Okay. In the meanwhile, some students are just noting this down. I'll tell you. Now the next thing which we are going to do is indices. Now indices is of utmost importance to us in mathematics. वो चाहे 10th हो, चाहे 11th हो, चाहे 12th हो, चाहे जो मर्जी स्टैंडर्ड हो, इंडाइसिस के ऊपर स्ट्रॉन्ग ग्रिप होना बहुत जरूरी है. एंड ऐसा नहीं कि इंडाइसिस सिर्फ एक या दो चैप्टर में यूज होता है. इंडाइसिस इज यूज्ड far and wide across almost all the topics of mathematics. So now we are going to do indices. And indices में हम लोग है ना, particularly we are going to pick some little, we'll start with some simple ones and then gradually we will increase the level of difficulty. So now the students who said कि ये बहुत easy है, चिंदी है, ये simple है, now here we are going to use our brains a little bit. So I want everybody to be focusing when we are doing indices. Indices से पहले ना, before we start solving sums based on indices, we should be knowing the laws of indices or the rules of indices. Okay, it's very, very important. Rules of indices. अब rules of indices में क्या क्या rules आते हैं मैं आपको बताता हूँ. ज्यादा नहीं है, 5 ही है और बहुत आसान है. It's very, very easy. And for indices this time we are going to pick up little complex questions because I feel most of the students feel कि ये सब तो बहुत easy है, ये तो देख के आ जाता है. तो इस बार indices के लिए I am going to pick up questions which are going to be like real brain teasers. So you will enjoy doing them. Now, number 1. Indices का जो पहला rule है ना, उसे हम कहते हैं product rule. Product rule. And I'm sure most of the people must be knowing what product rule is. It says that a raised to m multiplied by a raised to n is equal to a raised to. What is going to be a raised to? It is going to be m plus n. A raised to m plus, sorry, into a raised to n is equal to a raised to m plus n. Perfect. Now, the second one. This is called as the quotient rule. Quotient rule. Now, a raised to m divided by a raised to n. So a raised to m divided by a raised to n is going to be a raised to m minus n. This is called as the quotient rule. Please do write it along with me because we'll be needing them. That's perfect. A raised to m minus n. Fantastic. तो प्रोडक्ट रूल में जब वो बेसिस मल्टीप्लाई होते हैं तो पावर्स ऐड होते हैं. क्वोशिएंट रूल में जब बेसिस डिवाइड होते हैं तो जो प्रोडक्ट है उसका जो पावर्स है वो सब्ट्रैक्ट होता है. बट द बेसिस हैव टू बी सेम. Now let us come to the third rule. This is called as the index rule. Index rule is a raised to m, the whole raised to n. A raised to m, the whole raised to n becomes a raised to m into n. This is the index rule. Now the fourth rule, perfect. The fourth rule which we are going to study now, this is called as the reciprocal rule. ये बड़ा important rule है. Reciprocal rule. Now you just be attentive for the reciprocal rule. देखो, ये हम ना बहुत ज्यादा यूज करने वाले हैं आज के सेशन में. So a raised to the negative m. Now you see the base is a and the power is negative, that is minus m. Now suppose if we have to make the power positive, अगर हम लोग को ये पावर का साइन चेंज करना है, अगर मुझे m का साइन चेंज करना है तो मुझे क्या करना पड़ेगा? I will have to reciprocal the base. Perfect, fantastic. So if I reciprocal the base, तो a जो है ना, that is the base, it becomes 1 upon a. So when you reciprocal the base, minus m turns out to be m. See, base को reciprocal करोगे तो साइन बदल जाएगा. It's very easy. Let's try this second one also. ये देखो, a upon b, the whole raised to the negative m. अब आप देखोगे एक बेस जो है ना वो फ्रैक्शन है, a upon b, and the power is negative. And suppose if we have to make the power turn positive, what are we going to do? Simple, base को reciprocal कर दो. So b upon a, when you reciprocal the base, the sign of the power changes. Fantastic, perfect. So when you change the base, when you reciprocal the base, the power will change its sign. Amazing. Now we're going to do the fifth rule. This is called as the unit rule, the most easiest rule of the indices. A unit rule का मतलब होता है anything raised to the power zero. किसी को भी अगर हम जीरो के पावर से अगर रेस कर देंगे, जैसे कि फॉर एग्जांपल a raised to zero, it is equal to 1. So this is called as the unit rule. Anything raised to the power zero is always equals to 1. For example, 5 raised to 0, 1. 10 raised to 0, 1. 50 raised to 0, 1. Any number raised to 0, it's always equals to 1. It's very simple. तो ये जो 5 laws है ना, 5 rules है, I hope you people have written this in your books. And then we start with some really interesting ones. That's zero. Done, great. Perfect. So I hope you people must have written this by now. All right, let's do some questions based on this. Some interesting ones. So we start with a very basic question. Now 5 raised to minus 4 multiplied by 125 raised to 5 upon 3 divided by 25 raised to minus 1 upon 2. Okay, we have a question over here. Now everybody please focus on the question. 5 raised to minus 4 multiplied by 125 raised to 5 by 3 divided by 25 raised to minus 1 by 2. Now, if you see all of them, all the bases, you can easily find out that we can turn the bases in the powers of 5. हम सारे के सारे bases को 5 के power में convert कर सकते हैं, जो कि बहुत ही आसान है. तो ये जो 5 है ना, we keep it as it is. 5 raised to minus 4. 125 है, which can be written as 5 cube, the whole raised to 5 by 3 divided by 25. 25 can be written as 5 squared raised to minus 1 upon 2. So we have converted all the bases in terms of 5. Can you tell me what do we do next? Out of all the rules which you have studied, which rule are we going to use now? Product rule, quotient rule, index rule? Okay, so the few students have given the correct answer. We are going to use the index rule. We're going to use the index rule, all of you. See, I'll tell you. 5 raised to minus 4 multiplied by 5 raised to, see, index rule, 5 raised to 3. The whole raised to 5 by 3 is 5 raised to 3 times 5 by 3. divided by, now this is 5 square, the whole raised to 1 upon 2. It's going to be 5 raised to 2 times minus 1 upon 2. So we have used the index rule over here. So यहाँ पे see 3 cancels out, 2 cancels out. Let us write whatever is left out. 5 raised to minus 4 multiplied by 5 raised to 5 divided by 5 raised to minus 1. All right. Now, as many of the students were suggesting, what do we do? Now we are going to combine the product rule and the quotient rule together. Perfect. The product rule and the quotient rule together. Now, in the first two of them, here, we are going to use the product rule. So in the product rule, what happens? The powers are going to get added up. So it's minus 4 plus 5. And in this case, it's division over here. तो power subtract हो जाएगा. तो जब power को हम subtract करेंगे, तो it's going to be minus of minus 1. Right? I also hope this is easy to understand. So we have 5 raised to minus 4 plus 5 turns out to be 1. Minus of minus becomes plus, which turns out to be 5 square, and the final answer is 25. So if you got this answer, then you're right. Great. जिसको ये आंसर मिला है वो बिल्कुल सही है. Amazing. Let's try another one. ये देखो. Again, I'll give you an easier one. See if you can do this. 27 upon 125. The whole raised to 2 by 3. Yes, we always have to apply the Bodmer's rule, not just to indices, but to everywhere. In mathematics, whenever we are dealing with numbers, we always have to use the Bodmer's rule. So 9 upon 25, the whole raised to minus 3 by 2. चलो ये वाला करके दिखाओ. See, I'll tell you what we have to do over here is, जो पावर जो होता है ना, जो पावर का डिनोमिनेटर होता है 3 और इस पावर का डिनोमिनेटर है 2. Try getting rid of this 3 and 2, which I have put in the red box. तो वो कैसे करेंगे हम लोग? Simple. If we have to get rid of this 3, अगर हम लोग को ये 3 निकालना है, तो ये जो बेस है ना 27 upon 125, raise it to the power 3. Raise it to the power 3. By which way you can do that? See. Now 27 and 125, you can easily note that they are 3 cube and 5 cube. So we simply write it as 3 upon 5, 3 upon 5, the whole cube, the whole raised to 2 upon 3, multiplied by, now once again, if we have to get rid of this square, so make this in the form of a whole square. Now 9 and 25, we understand that they are basically 3 upon 5 the whole square. So 3 upon 5, the whole square, the whole raised to minus 3 by 2. Fantastic. अब क्या करेंगे? Tell me which rule are we going to apply? Now this time we are going to apply the index rule. Fantastic. Perfect. तो चलो index rule apply करते हैं. 3 upon 5, the whole raised to 3 into 2 upon 3, multiplied by 3 upon 5, the whole raised to 2 into minus 3 upon 2. So I told you that we are going to get rid of the denominators of the powers, which I have put in the red boxes in the question itself. Now see, we can do that. यहाँ से ये 3 और ये 3 cut, ये 2 और ये भी 2 cut. So finally, we got rid of all of it. So whatever is left up, let us just write that. 3 upon 5, the whole square, multiplied by 3 upon 5, the whole raised to minus 3. Tell me, students, now which rule are we going to apply? we are going to apply the product rule. So we have 3 upon 5, the whole raised to 2 plus of minus 3. 2 plus of minus 3. So which turns out to be in the end 3 upon 5, the whole raised to minus 1. Perfect, that is the correct answer. But we do not like to keep the negative powers. तो अगर मुझे अपने पावर को पॉजिटिव करना है तो 3 upon 5 का रेसिप्रोकल कर देंगे 5 upon 3, and here we got the correct answer. I hope you people got this answer, those who were really trying it on their own. Awesome. Perfect, perfect. That's very nice. Great. Okay, here's another one which we could try. Yeah, my lecture is up till 8:30 and then we'll be done. Chilo students, let us try this one. Now this is an interesting one. 5 raised to n plus 3 minus 6 multiplied by 5 raised to n plus 1. The whole upon 9 into 5 raised to n minus 5 raised to n multiplied by 2 squared. Multiplied by 2 squared. So now this is a little thought-provoking question. So students, any ideas how you think you might be able to do this? Now here we are going to use the product rule, but this time we are going to use the product rule in the reverse order. I'll tell you how we're going to use it in the reverse order. See, a raised to m plus n. A raised to m plus n will be simply written as a raised to m multiplied by a raised to n. Observe carefully. A raised to m plus n is as good as a raised to m into a raised to n. Now we have 5 raised to n plus 3. So using the same rule over here, tell me how would we write 5 raised to n plus 3? It's simply going to be 5 raised to n multiplied by 5 raised to 3. I hope you people get this thing, right? So now the same thing we notice over here also. 5 raised to n plus 3. So 5 raised to n plus 3, we are going to write it as simply 5 raised to n multiplied by 5 raised to 3 minus 6 into. What about 5 raised to n plus 1? Any idea how do we write 5 raised to n plus 1? We're going to write it as 5 raised to n multiplied by 5 raised to 1, and 5 raised to 1 is as good as 5. Yes, Bhumi, you are correct. Upon. Now, 9 into 5 raised to n minus 5 raised to n into 2 squared is 4. All right, students. Now, it's simplified quite a lot. Can you tell me what should be your next move? First of all, you should know how to count the terms. Tell me, students, in the numerator, how many terms can you see? How many terms can you see in the numerator? All right, fantastic. तो बहुत सारे बच्चों को ना terms count करना नहीं आता है, तो I'll teach you how to count the number of terms. So if you have to count the number of terms, so we always see, हम लोग ऐसे नहीं count करते. See, बहुत सारे बच्चे बोलेंगे ये देखो, ये this is 1, 2, 3, 4 and 5 हो गया 5 terms. ऐसे नहीं होता students. Terms count करने के लिए हम प्लस या माइनस के इर्द गिर्द कितने terms है ना वो count करते हैं हम लोग. See, I'll tell you. This entirely is one term. यहां से लेके यहां तक. This entirely is a one term. तो प्लस या माइनस के आजू बाजू में कितने ना हम वो काउंट करते हैं. उसी तरह से डिनोमिनेटर में भी if you notice we have got two terms. One is around here, the other one is here. Now let us see what we can do over here. Do you see that in the first term 5 raised to n and 5 raised to n? Can we take out 5 raised to n common in the numerator? In the numerator, we can take 5 raised to n common. So when we take out 5 raised to n common in the numerator, what do we have inside? 5 cube. That is 125. And then we have 6 into 5. 6 times 5 is 30. Tell me, students, what do we do in the denominator? In the denominator also, we notice the same thing. We can clearly notice that 5 raised to n and 5 raised to n, we can notice over there. So we take 5 raised to n common outside. So let's do that. 5 raised to n is taken out common. What remains inside is 9 minus 4. And see, yes, we can cancel it out. Perfect. 5 raised to n upon 5 raised to n is cancelled out. What is left out is this. 125 minus 30. So 125 minus 30 leaves you 95. And 9 minus 4 is equal to 5, which is equal to 19. So 19 is our answer. I hope you people got that answer. And if you got so, that's really good. That's amazing. Chalo. I hope we can try one more question in the time left. एक इसी के जैसे क्वेश्चन आपको देता हूं of the same type. And after learning this one, I am sure you'll be able to crack this one. So here we go with the question. See, the question is 3 raised to a plus 2 minus 3 raised to a plus 1 the whole upon 4 into 3 raised to a minus 3 raised to a. Okay, this is a much more easier version than what you can see over here. I'm sure आप लोग खुद से ये पक्का try कर सकते हो. Are you people trying this? All right, perfect. Great. Awesome. Oh, so many students have started giving the answer. Yes, Avishkar, your answer is correct. Sonali, your answer is correct. Bhumi, your answer is correct. Yash, Manal, all the answers are correct. Awesome, you guys are. Mayanka, your answer is correct. Chalo. In case those who are still, Aditi, your answer is also correct. Perfect. That's very nice. Yeah, all of them are correct. Unnati correct. Okay, chalo. Those who got the correct answer, fantastic. In case some of the students are struggling with the correct answer, let me help you do that. So ये हो जाएगा. See, we're going to go backwards here. So 3 raised to a into 3 square minus 3 raised to a into 3 raised to 1 as good as 3. What do we do in the denominator? Again, in the numerator, in the denominator, we straight away take 3 raised to a common over here. We simply take 3 raised to a common. So when we take 3 raised to a common, what remains inside is 4 minus 1. So numerator में से 3 raised to a common निकालेंगे तो अंदर बचेगा 9 minus 3. 3 raised to a upon 3. So 3 raised to a, 3 raised to a gets cancelled. 6 upon 3 and the answer is 2, which most of the students have got and I'm really happy. Perfect. All right, Chalo, let's try one more. See, this one is also very nice. Now, a raised to n upon a raised to n, the whole raised to m plus n, multiplied by a raised to n upon a raised to l upon n plus l, multiplied by a raised to l upon a raised to m, the whole raised to l plus m. Now we got to simplify this. We got to simplify this. Can anybody just think in your head कि इसको क्या करना चाहिए before you simply start writing it down? फटाफट फटाफट लिखना शुरू करने से पहले थोड़ा सा एक थॉट दे सकते हैं कि इसका एंड रिजल्ट क्या हो सकता है? ओह गुडनेस, आंसर आ भी गया। फैंटास्टिक। चलो, let us use first the quotient rule. A raised to m upon a raised to n is equal to a raised to m minus n, and the whole upon m plus n, into a raised to n upon a raised to l is equal to a raised to n minus l, the whole raised to n plus l. Okay, multiplied by a raised to l upon a raised to m is equal to a raised to l minus n, the whole raised to l plus n. So now we are going to use our index rule. And index rule तो आपको देखते ही पता चल जाएगा कि क्या होने वाला है. See, a raised to m minus n, the whole raised to m plus n. It is simply going to be a raised to m minus n into m plus n is m square minus n square, multiplied by a raised to, this is going to be n square minus l square, multiplied by a raised to l square minus m square. So this is all a plus b into a minus b becoming a square minus b square. Okay, perfect. So now we are going to finally use our product rule. Now all the powers are going to get added up. A raised to m square minus n square plus n square minus l square plus l square minus m square. All the powers are getting added up. So this time, let's see. M square minus m square get cancelled. Minus n square plus n square gets cancelled. Minus l square plus l square gets cancelled. Everything gets cancelled. We left out with a raised to 0. And as per the unit rule, it's equals to 1. Perfect. So that's good. All right. So one more interesting thing. Let's do this one. So it's going to be a very simple one. We're going to wind it up very quick after that. I hope you people have done this. So now we'll be solving exponential equations. I'll tell you what this means. It sounds very fancy, exponential equations, but hota bahut hi aasan. Ye dekho. 4 raised to 2x is equal to 1 upon 32. Now, what do we mean by exponential equations? Yani solve ka matlab hota hai we basically have to find the value of the variable. And in this case, the variable are in the powers. The variables are in the powers. So that x you see, it is basically as the power of 2. How do we solve these type of equations? ये x की value कैसे find करते हैं? बहुत आसान है. We have to simply make the bases equal. Always remember this rule. Bases equal, तो powers equal. Hence powers equal. चलो, तो हम लोग क्या काम करते हैं? 32 को ले आते हैं numerator. Let's get 32 to the numerator. So what does that happen? 4 raised to 2x is equal to, let us use the reciprocal rule. तो वो हो जाएगा 32 raised to minus 1. The whole idea is to make the bases equal. तो ये जो 4 है और ये जो 32 है, इसको हमें सेम करना है. और वो हम कैसे करेंगे? We can actually write 4 and 32 in terms of 2. 4 जो है ना 4, we can write it as 2 squared. 4 can be written as 2 squared. The whole raised to 2x. And 32, for your information, is basically 2 raised to 5. 2 into 2 into 2 into 2 into 2. If you multiply it 5 times, you end up getting 32. That's 2 raised to 5. The whole raised to minus 1. So we have 2 raised to 4x is equal to 2 raised to minus 5. Now, the moment we get the bases equal, we can simply equate the powers. So we get 4x is equal to -5. If the bases are same, the powers become equal. So x equals to -5/4. This is the answer. I hope you got this answer. वैसे मेरे बहुत सारे बच्चे आंसर्स दे ही रहे थे. तो चलो एक काम करते हैं, इसी के साथ आज का सेशन खत्म करते हैं यहीं पर. अगले सेशन में we will do something more interesting. So we will stop here. Good night all of you. Take care.